Assalamu alaikum, Ali, can you hear me?
Walaikum Assalam, I can hear you.
Ali, what is the status? What papers you have done? I'm also sharing past paper, yearly papers also. And I'm doing yearly topical theory, different groups, different things. And with you, I'm doing topical also. But I have done yearly in another group and I've shared the video. Hopefully, you are following the track. The latest papers are very important. So can you give me a brief in this? Force is a vector quantity. State 3, other vector quantities.
There's acceleration, there's displacement,
Anyone
and
and
velocity.
velocity. Good one. So any three can be given. Three coplanar forces. Coplanar means they are on the same plane. They are sharing the same plane. Act on an object as shown. The force Z is vertical and X is horizontal. The force Y is at an angle theta to the horizontal. The force Z is kept constant at 70 Newton. In an experiment, the magnitude of force X is varied. He says X can vary. The magnitude and direction of force Y are adjusted so that the object remains in equilibrium. Equilibrium means resultant force is equal to 0. The figure shows the variation of the magnitude of the force Y with the magnitude of force X. He's changing X and Y, and always, as usual, is trying to make a good game about it. Use figure 3.2 to estimate the magnitude of Y when X is equal to 0. So X is equal to 0 means I should extend this graph. I should extend this graph. I have extended it. Now, this is the point where X is equal to 0. Can you read this value? What is this Y-intercept?
68.
68. 60 in between. 62, 64, 66, 68. Yes, good guess. State and explain the value of theta for X is equal to 0. Value of theta for X is equal to 0. When X is equal to 0, if examiner says X is equal to 0, so there is no X. He says what would be the angle theta for X is equal to 0? There is no X, only Y is there and Z is there. Now it's a tricky question and no good space is given, only lines are given. So if there is no X, how an inclined force Y can balance Z? That's a very thinking question. I do not draw X now, and I draw only the downward force and an angular force.
So it
Y
will be
and
more
Z.
than 90.
You are close, but why more than 90? You can see this diagram, how you can think Y can balance out Z alone. Don't you think Y should be exactly facing Z?
In the opposite direction.
Very good. It means if I move Y, I should get Y exactly opposite to Z. And in this case, what would be
Then it
the
will be
angle with X?
180.
Hey? No, no.
90 degrees.
90. How it can be 180? 180 means the total angle. That is not required. So how should I explain it?
When x is 0, then y will cancel the effect of z.
Sorry, I couldn't hear you.
When x will be 0, then y will cancel the effect of z.
Huh, because of the concept of equilibrium. So you will write theta is 90. Y should be facing Z to balance it. Okay, the magnitude of X is increased to 160. Use resolution of forces to calculate the value of angle theta. Magnitude of X is increased to 160. Okay, but what about Y? Achha, Y is asking. Okay, so it means Y won't be given to me. And let's draw a diagram. You should draw a diagram with me as I'm drawing. So that will be a good practice, which I always say. You should draw a neat diagram so examiner can be happy on that and the presentation is good. Resolution is something which is a very, very important topic. So I have drawn axis ready for the work. And this angle is theta. This is Y. And this is 160 X. How much is downward force is Z, and Z is 70. Which force should I resolve? I cannot resolve every force, right? which
70.
force?
The y cos theta.
Now I'm thinking, I don't have actually, I don't have Y. Why? He's asking Y in the next part. I need to find angle. So hopefully you have done with me this much work, and I always emphasize that people should do work with me because this is the only way to remember things. Now, what should I do? I am here in this point. I have two equations. So should I solve them simultaneously?
The trigonometric rules can't be used here, like this sine cos tan.
We can use, you're right, but that's the same thing. I'm using the same trigonometry, no? How we divide equations?
by
Can I
making a ratio,
cancel? Huh?
we'll make the ratio and then divide it.
Yes. Division is simple. In mathematics, you can divide equations left to left, right to right. It's a very powerful method. It's a ratio method. Or otherwise, you can take out value of y and put it in the other equation. Now, can I cut y and y?
Yes.
Can you tell me what is sine upon cos? It's a property to remember for A level. Do you know this property?
Yes, and there was one other one like sine 90 minus theta is equal cos theta.
Ah, good. So that's a good point. And sine theta upon cos theta is equal to tan theta. So calculator should be in degree mode.
It is coming as 23.6.
20.
23.6 degrees.
Very good. The magnitude of force y
I'm getting 174.8 and 175 Newton.
175. Okay. 175 is three significant figure.
First, I was getting 174.8.
Acha, acha, acha. Then it's fine. The angle theta decreases as y increases. Why the object cannot be in equilibrium when theta is equal to 0? Now, that's a very interesting question again. If you make theta 0, the y will come down and it will come in focus with x. So if you make 0, you will have a diagram like this. Now, in this diagram, you can say that it is possible that y balances x, but z will remain unbalanced. So it means it cannot be in equilibrium. Equilibrium require every force to be balanced. Did you get this point?
Yes, as x balances the y, but z remains unchanged.
Z is facing it, and there's nothing to balance it. So when there is an unbalanced force, the system will be system can't be in equilibrium. Compare the molecular motion of a liquid with a solid with a gas. This is a very fundamental type question, even though it is not an official topic now. It was a topic, but anyways, in a solid, molecules vibrate. In a gas, molecules move random. A ductile material is in the form of a wire is stretched up to its breaking point. On figure, sketch the variation with extension of the stretching force. A ductile material has two types of deformation before it breaks. One is the elastic deformation, and second is the elastic deformation, and second is the
Plastic.
plastic deformation. Now I have made a sketch. This is I have made it from memory, so it's a memory case. Sketch the variation with extension of the stretching force for a brittle material up to its breaking point. Brittle materials like glass, do they undergo plastic deformation?
No, they just break.
Yes. It has only one line. It breaks on that line. Describe a similarity and a difference between ductile and brittle material. The similarity, they both undergo elastic deformation. They both obey Hooke's law. And what is the difference? Brittle materials do not offer plastic deformation, while ductile materials offer plastic deformation also. This topic is not in course now. This topic is not in course. A rod PQ is attached at P to a vertical wall as shown. The length of the rod is 1.6 meter. The weight of the rod x 0.64 meter from P. The rod is kept horizontal and is in equilibrium by a wire attached to Q and to the wall at R. The wire provides a force F on the rod of 44 Newton at 30 degree to the horizontal. Determine the vertical component of F. Vertical component of F. So you can say that you should go for a resolution of forces determine the vertical component of F. Now, can you tell me what is the vertical component here?
The 44 sine 30.
Hmm. Horizontal component of F.
44 cos 30.
How much this will come?
38.1.
By using moments about P, he wants that you should take a pivot at P. Determine the weight of the rod. So I'm taking pivot at P, which looks to be a good pivot. So if I take pivot at P, I have a moment by W and I have a counter moment by F sine theta. Should I consider in moment case F cos theta, which is going directly from the pivot? F cos theta arrow is going
No,
in the pivot. No,
it won't
we
be
will not consider F cos theta. The rule is there. If a force is going through the pivot, you will not consider it in moment because it can't create any moment. Now, W and 0.64. W into 0.64 and F sine theta into 1.6. F sine theta is precisely 22.
It is coming as 55 Newton.
W. Explain why the wall must exert a force on the rod at P. Why the wall must exert a force at P. You can see here, is there a force going in P?
The F cos 30. Okay. So Newton's third law.
So you need a reaction force to balance it. Otherwise, the rod will not be stable. Draw an arrow to represent the force acting on the rod at P. Label your arrow with the letter S. Now he says, that what would be the direction of the force?
It will be the F cos 30.
Will be F cos 30. Why? He's asking for the new force, which is balancing F cos 30.
So that will be the other direction.
That would be the other direction. November 15. The figure shows a metal cylinder of height 4.5 and base area 24. The density of metal is this. Show that the mass of the cylinder is this. He has given us density and volume we can find. So how we can find the volume first?
Base area into height.
Yes, mathematics. Centimeter square. What answer we get? He has not given us any unit.
So will we divide that by 10 power 6?
Yeah, actually 1 meter is equal to 100 centimeter. Na? So you have to
So cube the 100.
square na area. Volume is V. Then first you have to find volume and then you have to find mass.
It is coming as 0.085.
What?
The answer.
Sure. Looking to be a very small number.
But it says show 0.85.
So our extra zero is coming from, what is the possible reason? 24. Can you check your calculation again? Because I'm not getting any error reason.
Yes, now it's coming fine. I added one extra zero.
Oh, acha. So it means now it's coming fine. Again, it looks to be an inclined plane, one of their favorite topic. The cylinder is placed on a plank as shown. The plank is at an angle of 40 degree to the horizontal. Calculate the pressure on the plank due to the cylinder. Oh. We need to find that we need to make a logic here because
Will we use the force over area and take the mass as the force weight?
but the problem is that it's on an inclined plane. So the whole weight cannot produce the pressure because it's on an inclined plane. Na? So angle is there. So I made a working here and you can also join me for this working because this working is important. So this angle will be 40. This is mg. Now share this diagram and now you can see which component should I take for pressure.
Pressure mg cos 40.
Right. So why I should not take mg sin 40?
Because that is not in the direction of the weight.
So pressure is equal to force upon area. (24)
It's coming as 2661. We'll add
Sorry,
2661.
2. Can you convert it into scientific?
2.6 into 10 power 3.
The cylinder then slides down the plank with a constant acceleration of 3.8. The constant frictional force act on the cylinder. We have to go to the cylinder again. He says cylinder is coming down and this is friction. Now, how I make this equation? What's the formula for resultant force? Resultant force is always equal to greater force minus smaller force. Right? So I use that idea. Greater force minus smaller force is equal to MA. Now I have everything. We need to find friction. We need to find friction.
I'm getting 2.13.
Can you repeat 2.12?
Yes, 2.13.
Okay, 1213 is fine. Now, this is the first part. Define moment of a force. Can you get the definition for me?
Force into distance, and the distance will be the perpendicular distance from the line of
Moment is
touching.
the product. Moment is the product of the force and the perpendicular separation from the pivot. An arrangement for lifting heavy loads is shown. A uniform metal beam is pivoted on a vertical wall at A. The beam is supported by a wire joining end B to the wall at C. The beam makes an angle of 30 degrees with the wall and the wire makes an angle of 60 degrees with the wall. So much data is given. The beam has length 2.8 and weight 500. A load of 4,000 Newton is supported from B and tension in the virus T, the beam is in equilibrium. So that's a point to know, be noted that beam is in equilibrium. Now he says taking moment about A. So pivot is at A.
Can you give me 1 minute?
Uh-huh. No problem. I'm just, you let me know once you are back.
Yeah, I'm here.
By taking moment about A, show that T is equal to 2.1 kilonewton. So T is there. We need to find, should we go for resolution? It's a 30-degree with x-axis, and we have, I think T is already making a 90-degree angle. So we should make our own diagram. There is a rod AB. And one force is T. And this force is making an angle 90. If this is right, and that's a tricky part. What's about, it looks 90, but how we can confirm it? Can you help me in trigonometry? If I have one angle 60, one angle 30, can you prove to me that the B angle is 90?
So alternate angles.
No,
We
no,
can
sum
use
of
that.
angles in a triangle.
Okay, sum of the interior angles is equal to the sum of
No,
that.
no, no. If this angle is 30, this angle is 60, what will be this angle?
90.
Yes, because 30 plus 60 is 90 and 180 minus 90 is also 90. So if you can prove by this method. Acha, now we should go and we should make our diagram again. And we have a 500 Newton and 4000 Newton. If this angle is 30, the angles they are making will also be 30 alternate angles. So this angle is 30 and this angle is also 30. So I have made the diagram and now moment about A show that T is equal to 2.1. So should I resolve these two vectors for 500 and 4,000?
Into cos and sine.
We should resolve them. This is the thing. It's facing T. I think now we can find T. Because when forces are facing each other, they should be considered equal. This is apparent to be a direct method, but let's try that.
It is coming as 2000. I didn't understand this question like completely.
This question is obviously it's a bit tricky one, or we should make a complete equation. I think that a risky method because I'm directly equating it, and I'm not taking the clockwise and anti-clockwise moment. If I take
Because
the bolo.
down it also says to take the vertical component. So the vertical won't be like this one.
No, I think we should go for that clockwise moment is equal to anti-clockwise moment. And that would be much safer because it will accommodate every component. If I make a line here also. So if I resolve this, it will be 500 sine. So I have made all the component. What is the length of the rod? It's 2.8, right? The length of the rod is 2.8. And how should we make the equation?
We'll take the clockwise moments and then the anti-clockwise.
We should make the clockwise moment and anti-clockwise moment. So T is going upward. So I will take T into 2.8. T into 2.8 and then I equate it and I have 500. I have 500 sine 30. 500 sine 30 into 1.4 plus 4,000 sine 30 into 2.8. Now that looks to be a better equation. It covers everything.
Yes, it is coming as 2125.
Hmm. Can you repeat the value? 2000?
125.
Calculate the vertical component TV of the tension.
It will be 4000 sine 30.
We have to see the vertical component of tension is asking. So it will be vertical and horizontal. There are always two components if you resolve it. But for that, you have to take an angle with that, and there will be a vertical component. So if I draw a line here and draw a line here, and then I resolve it, I will get an angle 60 here. Diagram is so small. Then I will get a vertical component as T cos 60. This is how we resolve it. So vertical component TV will be equal to T cos 60. State and explain why TV does not equal the sum of the load and the weight of the beam, although the beam is in equilibrium. Now he's saying that this is the vertical component TV. Why it is not equating these two forces?
Because of a different angle.
Different angle plus different position. So TV can balance 4000. It's facing each other, these two forces, but how it can balance 500, which is on another position, plus there will be some force on the position A. There will be some force on position A, and T cos 60 cannot balance it because it is not acting on the same position. It is a very similar question. If I ask you that I apply a force X here, X can balance Y, but how X can balance Z? It is not in line of it. Forces can balance each other if they are in the position, if they are on the common point. So the answer would be there will be some force on position A also, and TV cannot balance all the forces. So this was a difficult question, and we completed it. Now we keep it up to here, and I will post my next class. I've been asking all my students to take yearly paper classes also if they are free on that time, because slots are busy. Everyone is doing past paper, but yearly past paper I have started with other groups also, and I will post the timing. What you should do, that you should keep on doing the range, which is the latest paper range, and keep on attending this topical paper, because topical past paper still have very important features. You can learn a lot when you do one topic question. So we keep it up to here, and we will inshallah do it in our next class. Allah Hafiz.
Allah Hafiz.